Electrical box spacing is governed by the National Electrical Code, often abbreviated as NEC. The NEC mandates a maximum spacing of 4 feet between electrical boxes along a wall. However, for walls exceeding 8 feet in height, an additional electrical box may be necessary to comply with the code. Now let's talk about the wire jacket. The jacket is the outer covering of electrical wire, and it serves as a protective layer for the conductors inside. The National Electrical Code specifies that a minimum of 6 inches of electrical wire jacket must be present inside the electrical box. This requirement helps to ensure proper insulation and prevents strain on the wire connections. Bonding is another critical aspect of electrical safety. Bonding involves connecting electrical components together using a conductive material. This creates a low-resistance path for electrical current, which is essential for grounding and preventing electrical shock hazards. In a typical residential setting, bonding includes connecting the electrical system to metal water pipes and gas piping. This connection ensures that any stray electrical current will safely flow to ground, minimizing the risk of electrical shock. As for wire size, the minimum required wire size for most residential applications is 14 gauge for 15 amp circuits and 12 gauge for 20 amp circuits. However, it's important to note that larger wire sizes may be necessary for longer runs or higher amperage loads. Using the correct wire size is crucial for preventing overheating and potential fire hazards. Now let's expand on each of these points in more detail. Firstly, spacing between boxes. The 4-foot rule is generally applicable to receptacle outlets installed along a wall at the floor line. The intention is to ensure that no point along the wall is more than 6 feet from a receptacle outlet. This is to accommodate common lengths of appliance cords. There are exceptions to this rule, for example, in kitchen countertops. Also, dedicated receptacle outlets for specific appliances like refrigerators or washing machines do not need to adhere to this spacing requirement. Regarding walls over 8 feet tall, the purpose of adding an additional box is often for a lighting fixture or a switch. The specific requirements for these installations depend on the intended use and the local electrical codes. Always consult the NEC and local regulations for the most accurate and up-to-date information. Secondly, let's delve deeper into the amount of jacket in the box. The 6-inch requirement for the wire jacket inside the electrical box is intended to provide sufficient insulation and protection for the conductors. This helps to prevent shorts and other electrical hazards. The jacket also provides mechanical protection to the wires as they enter the box. It's important to carefully remove the jacket without damaging the insulation of the individual conductors. Use appropriate tools such as wire strippers to avoid nicking or cutting the wires. When connecting wires inside the box, ensure that the connections are secure and properly insulated. Use wire connectors that are appropriate for the size and type of wire being used. Thirdly, bonding is essential to understand. Bonding creates an electrically conductive path that ensures all metallic parts of the electrical system are at the same electrical potential. This is crucial for safety, as it minimizes the risk of electric shock. In addition to bonding to metal water pipes and gas piping, bonding is also required for other metallic components such as metal enclosures, metal conduits, and metal equipment grounding conductors. The size of the bonding conductor is determined by the size of the service entrance conductors. Refer to the NEC Table 250.102 for the appropriate bonding conductor size. It's also important to ensure that the bonding connections are clean and free of corrosion. Use appropriate connectors and techniques to create a reliable bond. Fourthly, let's discuss wire size in more detail. The ampacity of a wire, which is its current carrying capacity, is determined by its gauge and insulation type. The NEC Table 310.16 provides ampacity ratings for various wire sizes and insulation types. For example, 14-gauge copper wire with type THHN insulation has an ampacity of 15 amps, while 12-gauge copper wire with type THHN insulation has an ampacity of 20 amps. When selecting wire size, it's important to consider not only the load on the circuit, but also the length of the wire run. Voltage drop can occur over long wire runs, which can reduce the voltage available at the load. To minimize voltage drop, use a larger wire size. The NEC provides guidelines for calculating voltage drop. When installing electrical wiring, always follow safe practices. Turn off the power to the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment. If you're not comfortable working with electricity, it's best to hire a qualified electrician. Let's consider some additional factors that can influence wire size selection. Firstly, ambient temperature. The ampacity ratings in NEC Table 310.16 are based on an ambient temperature of 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than this, the ampacity of the wire must be derated. Secondly, number of conductors in a raceway or cable. If multiple current-carrying conductors are installed in a raceway or cable, the ampacity of each conductor must be derated. This is because the heat generated by the conductors can raise the temperature inside the raceway or cable, reducing the ampacity of the wires. Thirdly, conductor insulation type. Different insulation types have different temperature ratings. For example, type THHN insulation is rated for 90 degrees Celsius, while type TW insulation is rated for 60 degrees Celsius. When selecting wire size, it's important to choose an insulation type that is appropriate for the application. Let's talk about some common wiring mistakes to avoid. Firstly, using the wrong size wire. Using a wire that is too small for the load can cause overheating and potential fire hazards. Secondly, making loose connections. Loose connections can cause arcing and overheating. Thirdly, damaging the wire insulation. Damaged insulation can create a shock hazard. Fourthly, overloading circuits. Overloading a circuit can trip the breaker or fuse and can also create a fire hazard. To avoid these mistakes, always follow the NEC and local electrical codes. Use appropriate tools and techniques, and if you are not comfortable working with electricity, hire a qualified electrician. Now, let's address specific scenarios related to bonding. In addition to bonding metal water pipes and gas piping, it's also important to bond other metallic components of the electrical system. This includes metal enclosures, such as electrical panels and junction boxes. It also includes metal conduits, which are used to protect and route electrical wiring. And it includes metal equipment grounding conductors, which provide a path for fault current to return to the source. The size of the bonding conductor is determined by the size of the service entrance conductors. Refer to the NEC Table 250.102 for the appropriate bonding conductor size. It's also important to ensure that the bonding connections are clean and free of corrosion. Use appropriate connectors and techniques to create a reliable bond. In some cases, it may be necessary to use a bonding jumper to connect two or more metallic components together. A bonding jumper is a short length of wire that is used to provide a low impedance path for fault current. The size of the bonding jumper is determined by the size of the largest equipment grounding conductor in the circuit. Now, let's discuss some common questions related to wire sizing. Question 1. What is the difference between 12-gauge and 14-gauge wire? 12-gauge wire is larger in diameter than 14-gauge wire and therefore has a higher ampacity. 12-gauge wire is typically used for 20 amp circuits, while 14-gauge wire is typically used for 15 amp circuits. Question 2. Can I use 14-gauge wire for a 20 amp circuit? No, you should not use 14-gauge wire for a 20 amp circuit. 14-gauge wire is only rated for 15 amps, and using it for a 20 amp circuit can cause overheating and potential fire hazards. Question 3. What happens if I use a wire that is too small for the load? Using a wire that is too small for the load can cause overheating and potential fire hazards. The wire will heat up due to the excessive current flow, and this can damage the insulation and potentially start a fire. Question 4. How do I calculate the correct wire size for a circuit? To calculate the correct wire size for a circuit, you need to consider the load on the circuit, the length of the wire run, the ambient temperature, the number of conductors in a raceway or cable, and the conductor insulation type. The NEC provides guidelines for calculating voltage drop and ampacity derating. If you're not comfortable performing these calculations, it's best to hire a qualified electrician. Let's examine the National Electrical Code, or NEC, in more detail, and how it relates to these concepts. The NEC is a comprehensive set of standards for safe electrical installations. It is updated every 3 years, and it is widely adopted by states and municipalities in the United States. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for anyone working with electricity to be familiar with the NEC. The NEC is organized into chapters, articles, and sections. Chapter 1 covers general requirements, Chapter 2 covers wiring and protection, Chapter 3 covers wiring methods and materials, Chapter 4 covers equipment for general use, Chapter 5 covers special occupancies, Chapter 6 covers special equipment, Chapter 7 covers special conditions, and Chapter 8 covers communications systems. Each article in the NEC covers a specific topic in detail. For example, Article 210 covers branch circuits, Article 250 covers grounding and bonding, and Article 310 covers conductors for general wiring. Each section in the NEC provides specific requirements for a particular aspect of electrical installation. For example, Section 210.12 covers arc fault circuit interrupter protection, Section 250.50 covers grounding electrode system, and Section 310.16 covers ampacity of insulated conductors. The NEC is a complex document, and it can be challenging to navigate. However, it is essential for ensuring safe electrical installations. There are many resources available to help you understand the NEC, including training courses, online forums, and publications. If you're not sure about something, it's always best to consult with a qualified electrician. In summary, understanding electrical box spacing, wire jacket requirements, bonding, and wire sizing is crucial for safe and compliant electrical wiring. The National Electrical Code provides the guidelines and standards necessary to ensure the safety of electrical installations. Always consult the NEC and local regulations for the most accurate and up-to-date information.